So I'm Craig Young. I'm a security researcher with Tripwire Vert, and I'm here to talk to you today about some research that I did last year on smart home hubs and some vulnerabilities that we found in there. So a little bit about me. I'm a security researcher, as I said. I develop content for our IP360 vulnerability scanner, and then I also do a good bit of original research and like to break things, find bugs. So the motivations for this project, we were kind of seeing that there are a whole lot of these different smart home hubs and connected light bulbs and locks and motion detectors just flooding the market. So you can go to Home Depot now and you've just got several aisles of these things. And I've had a lot of experience with hacking on embedded devices, and in my experiences, generally the consumer products that are embedded devices don't tend to hold up very well in security. They tend to have a lot of the same types of flaws. So the research that I did in here found flaws in the products that you're going to see. It was really not very difficult. These are all low-hanging fruit, which is a reason that people need to be looking at this stuff and identifying what else needs to be done. So we've got to talk about the reasons that somebody might target a smart home, what kinds of vectors they have towards it, and also what consumers can actually do to try and defend against these types of attacks. So the products that we analyzed, you've got the Wink Hub from Quirky, the Miosphere Lite, and the SmartThings Hub. We're going to go through first a little bit of background information about home automation and also what happens if you get attacked. And then we'll go through the case studies of each of the specific products that we reviewed. And of course, there'll be some closing remarks about next steps and stuff like that. So here is a graphic from Washington State University showing where they're seeing that smart home technology is going to go in the future. You can see you've got a lot of components scattered throughout the house, everything from garage door openers and motion sensors to things like something to control your sprinklers based on the weather or turn on and off your lights. So there is a bit of information that gets disclosed by these devices, as we'll see. The role of the hub, which is the point of which we actually researched, or I actually researched on this, this is creating a bridge between a wireless network within your home, so more like a personal area network that might be connected between some light bulbs, a control panel, things of that nature. These protocols normally don't extend beyond the house, but in the case of a smart home hub, you're giving it a bridge to connect to the internet and be able to access this functionality from a smartphone or a website. So one of the primary technologies that's used for those personal area networks is Zigbee. Zigbee is a protocol running around 2.4 gigahertz. You've got that one topology is what you get out of it. You've got for Zigbee, you actually have star tree and mesh, and you do have options for encryption, and this is licensed by the Zigbee Alliance, so everything has to be compatible with their standards. Some of the research that's gone on in the past here at DEF CON and other places, you've seen capture devices for sniffing on Zigbee networks, as well as injecting frames, and also doing different key-based attacks, like being able to reset keys, capture keys when a device is being initially provisioned, and things of that nature. So ZWave is the other big standard out here. This one is the one that only does a mesh network. It is also only available with the Sigma certifications for the ZWave stacks. And you also have support for encryption on this one, although it's not necessarily always used. With ZWave, we saw that at Black Hat 2013, there were attacks being demonstrated for sniffing keys off of the initial provision, similar to Zigbee. And also, if you don't have nonces implemented on this technology, you're able to sniff out messages and replay them. There was also one particular attack where they had shown that this lock that they had, they could actually trick it into thinking that they were the controller and reset the key on it to be able to take complete access from it. And they created this tool here that you see, ZForce, which works with the Texas Instruments CC1110 transceiver kit. That'll cost you about $75 for 2 transceivers and a debugging board if you want to start playing with ZWave. So it's important to think about what kinds of things happen if somebody breaches your smart home hub. First of all, of course, if somebody is gaining access to see when your garage doors are opened, what your thermostat's set to and when your lights are going on and off, these are all different things that are going to divulge information about your schedule. If you also have a connected lock in the system, somebody can then know when you're home, when you're not, and be able to come back and open up the locks, come into your house without your permission and do whatever they want. And the more pressing issue to me, though, because I don't really see it as realistic that these devices are going to be targeted by criminals breaking into homes so often right now, but the more pressing issue with this and all of the other IoT devices is that once somebody compromises them, they can actually use this to pivot into your home or just to start abusing your bandwidth for spamming, phishing, other types of things. So if we do see more and more devices like this taking off and consuming the internet, it could present a real danger to the internet if somebody wanted to use them to, say, launch a distributed denial of service attack on the DNS infrastructure. So the attack surface that we have here on the smart home hubs, we've got the ability to do, we've got the end devices, so you can go attacking the wireless protocols that are connecting the light bulbs and the locks and whatever it might be. You also have different tricks that you can do physically. Like, for example, it's been shown that if you want to defeat a motion sensor, oftentimes you just need to light a lighter, and the infrared energy coming off of that is going to deceive your motion sensor. Similarly, people have shown, of course, with magnetic door and window sensors, if you're able to keep a magnetic field on that, you're not going to trip it when you remove their magnet. So also with these products, since they're going over a network, we've got IP-based attacks and 802.11-based attacks. This is where I really focused on things, because as we'll see, if you're going after the edge devices or the end devices, you've got to know stuff specifically about those devices, the flaws in them, the protocols that they're using. You've got to be pretty close to them also, since these are short-wave or short-range protocols. If you're going with the physical countermeasures, this is probably going to have a good tendency to fail. You're going to need to know, first of all, what countermeasures are being taken at your target, and you're going to need to practice this. So for me, the IP space, that's really where I'm most comfortable, and that's what I focused on in this research, as well as a little bit of 802.11. So the first product that we'll look at, this is the Wink Hub by Quirky. It supports a variety of wireless protocols and also has smartphone application, web server, and web-based applications. If you do a port scan of this, you'll see the web server, and you'll also see SSH running. And then if we look back over Google and see what other people have done, you can see that last year at DEF CON, the GTV hacker group had actually put out an exploit showing how they were able to attack the device and gain root. This has been published, and they also showed that you were able to do some chip mucking and make the device believe that the system wasn't able to boot and take an alternate image. So really, any version of this, if you have physical access, of course you're going to get root. I didn't play with that type of stuff. I did use their command line injection initially on our box since it was unpatched so that I could learn a little bit more. But very quickly, I found that just grepping through that code, there were a whole lot of unsanitized select statements. This system is also running with SQLite, so if we wanted to, we can actually escalate permissions, because SQLite allows you to do an attached database command, which, since SQLite is running as root, as I said, you're able to create scripts anywhere on the box. You're able to create a PHP script that's going to backdoor the system. So then using CSRF, you're able to do a two-step attack and first implant the backdoor, and then second, call it to execute whatever commands you might like. Once you're in, you can start learning the victim's schedule or just abusing that bandwidth connection. So as I said, these are the steps that we had. There are some, if you wanted to use this in the field, the steps would probably be something like cracking somebody's wireless network and connecting directly to it, or perhaps sending out spamming emails, things like that, to try and get somebody onto a malicious page to attack the target. As we'll see a little bit later, it's not a problem to actually find it on the network through a malicious web page. So I also found while I was playing with this that there was a script on the box that would have it go back into its access point mode if you had not, or if it did not connect to a network within, I believe, 90 seconds, was it? So what you could do with this, if you're an attacker outside, you have no physical access, you can start performing a deauth flood on the victim's network. Their box is going to stop working. They're probably going to notice this at some point, reboot it, and when they do, as long as you maintain that deauth attack for the required amount of time, it's going to start broadcasting its open wireless network. You can connect directly to it, implant a backdoor, and then let it reboot. And for the owner, it will be working properly again, but it will actually be backdoored in this point. And also, if you were outside of the home, a lot of houses have external power breakers, so you could just cut the power in the middle of the night, reboot the box while you're sending out deauth messages, and then you've got another access vector. So with the Wink Hub, they were actually very responsive to this. They've implemented a bug bounty program, and they had fixed this bug several months back. I think pretty early this year this was fixed. It was initially discovered and reported to them in November 2014. Oh, also, with this and any other IoT device, you probably want to consider putting it on an isolated segment of your network so that you don't have as much of a risk of pivot attacks from it, but you're still going to risk somebody abusing your bandwidth in this way. So the next product that we're going to look at is this one that's sitting over on that chair. That's the Mios Vera Lite. It has support for a little bit more of a limited range of protocols. You've got ZWave Insteon, and it does have a Wi-Fi adapter in there. If you're going to scan this over the network, it's got HTTP and SSH, and it also has an interface for connecting via an Android app or an iOS app using the Vera infrastructure. Oh, it also has DNS or mask. So looking back over the Vera Hub, we saw that TrustWave Spider Labs had actually filed a report or published a report on an older firmware showing that you could do a lot of bad stuff with it. You could traverse firewall rules. You could run Lua scripts as root. Basically, you could own the box in a lot of different ways. Some of these problems, I believe, still might exist. I haven't taken the time to go through and verify those because there are a whole lot of other problems. There's, in general, not really authentication on the system unless you go and enable some other settings, which we'll talk about. You have no CSRF protection, so you've got unauthenticated pages that can be CSRFable, and then looking through their source files on their scripts, their shell scripts, there are several places for command injection through an unauthenticated HTTP request. So you also have the risk that this is connecting back into the vendor's infrastructure, and it's actually forwarding ports back into your home network. So if somebody did breach the vendor's infrastructure, they would be able to traverse right into all of the homes of people using this product potentially. So when we ordered this box, it was interesting. We got it over Amazon, and it came with these, what they call the UI5 firmware. Powering it up and configuring it and telling it to check for updates, it doesn't find any. It just says that it is up to date. However, we learned from the vendor that the UI7 firmware was available now, but you have to go to their website to a page listed as release candidate, and then you can download that or point your box to that, and then you will have firmware that didn't stop at 2012, but rather is somewhat actively maintained. However, it still seems to be in a beta state. Upgrading to the latest version of this, although they have made some changes in there to try and prevent command injection, they have failed at that. The fixes that they have can be very easily circumvented, and they have not communicated any information about when they intend to fix this. In general, the policy on this product seems to be that if you are a user on the local LAN, you're trusted, and not necessarily a great approach considering CSRF attacks. I did disclose this to the vendor, as I said, but it is still 0-day flaw, as verified with the latest firmware that was available from the UI7 train as of last night. Attacking this, probably CSRF is the biggest threat, or somebody breaking into your local LAN and connecting to it directly, of course. But I wanted to use this as an example of what I call smart CSRF. So the approach that we're looking at here is to use a stun server and actually identify the local IP address within the browser so that you can scan through the subnet and identify vulnerable devices there. You can see here as a reference for using WebRTC to do stun lookups. There is that GitHub project out there, which is very interesting. But now I'm actually going to show you how this vulnerability works, or show you an example of exploiting it. So on this line, running a script that is running a script in one console that is having a netcat server to send out a payload, and then I've got a web server running on another one. So I'll just go ahead and trying to pull up Chrome. All right, so over here, this is just a web server that's running on my local browser or on my local system. When I connect to this page via DC23, we're going to see that it's going to scan the network and connect back to this box, and you'll see these lights change their blinking pattern just to demonstrate root access. So as you can see, very quickly achieved that. You could also pull a shell with that technique. And so if you want to mitigate this problem, you probably just want to pull this thing out of your network. It's not a very secure device, but if you do have it or you want to be using it, the latest firmwares have an option for the secure Vera mode. When you enable this option, it's actually setting up IP tables rules to block any connections other than your outbound connections to their infrastructure, and I believe SSH might still be exposed. Moving along to the last device in the case studies, we've got the SmartThings Hub. This is pretty minimal attack surface on here. You've got the wireless protocols, which wasn't evaluating for the sake of this research. You've got the Android application interface, and then it's got a Telnet port open. A little bit odd that Telnet is running. They informed me that this was for diagnostics and is probably going to go away at some point, but I was not able to identify a password for it, so I did not use that. Looking over the web at previous research for this, back at the time when I started looking at it, there really didn't seem to be a lot of information out there. Eventually, afterwards, there was a report that we'll see in a minute, but when I looked at it, I actually found that using SSL split, it was very easy to just give it a fake SSL certificate. It would connect through and not care about that. Looking at the traffic underneath that, it seemed to be some kind of SSL VPN. So there could be some risk of somebody traversing into the network, but there's definitely risk of somebody being able to see data coming off of your network then. But it requires a network level attacker. And with this being a product that isn't going to be moving around or anything, it's not necessarily the biggest risk. They also did fix this very quickly. When I had reported it to them, they informed me that it was something they knew about. They were getting a patch out subsequently. I actually reported on this information in London at the InfoSec Intelligent Defense Conference last month, and in wake of that, there were several news stories being put out about this, and I was contacted by another researcher who had pointed me to his publication that came out this year. He actually had reported this to them 2 weeks before I did, and then when he looked a little bit further, found that the NCC group had reported this 2 weeks before he did. So it kind of goes to show that these types of things, they're not staying unknown. And also, as you can see with the TrustWave report from the Vera, those types of things are not being looked at alone. I mean, these have a lot of low-hanging fruit. So, as I said, they have implemented SSL checks for this. If you were to have a vulnerable system, it's not going to connect to their infrastructure anymore until it takes an update. So that's a good thing. That's a good result from this. So as a few closing remarks on this, I want to just mention for a moment again that the vendor infrastructure in these IoT devices creates quite a bit of risk for me. Meaning the fact that you have to create a tunnel going from the cloud into your home means that you're really putting a lot of faith in the vendor's security mechanisms, that they're not going to be compromised and expose your home network. It's also important to realize that these little things that we're connecting all over the internet, they need to be patched, and people need to be thinking about keeping them up to date just like you would with your regular computers. But unfortunately, that's probably not going to happen for a lot of cases. So as an industry, we need to be looking at different mechanisms for helping secure these things, either locking down the attack vectors, making sure that unpatched systems aren't going to remain on the internet for a decade. But this is really quite a difficult problem. And also, as far as CSRF threats, these get downplayed a lot, but we live in an age where everybody grabs smartphone apps and browser extensions, and these are systems that have access to do anything they want on your network generally. They can find out your IP address, they can scan through your subnet, and start popping systems on your LAN. So CSRF tokens are important even on IoT devices, definitely. So that's all that I have for today. If anybody has any questions, you can reach me over Twitter, or you can check out the Tripwire blog. Thank you.